Hello everyone. Today I'm going to talk about my prototype Telepod. This is a azimuth elevation controller for heavy cameras, and it can be remotely controlled. So if you're at an event, you can remotely control it so you could be in a different position or different area in the event and point the camera to wherever you want. Something like this would be useful for B or C video at remote locations that you don't have access to. The Telepod was made from all sorts of scrap metal and motors that were surplus motors, as well as using some VEX components, including the VEX microcontroller and some VEX limit switches and quadrature encoders. You can see the two motors. The big one on the top right is the elevation motor. It's very powerful. It's a very powerful servo motor, and it also has a built-in quadrature encoder, which turns out that it works perfectly with the VEX Cortex microcontroller. Although you can see a lot of wiring that looks like spaghetti, the wiring all works, and eventually it would be packaged into an enclosure so that it will look much neater. But for now, just to show how everything works, I'll keep everything exposed. The goal of this project is to show how you can interface VEX components to other types of components from other vendors, including motors, sensors, and different metal hardware such as the brackets used in this project. In order to remotely control the camera positioning, the camera angles in both azimuth and elevation, I use the VEX game controller shown here. As you can see, the game controller has 2 joysticks and it has 12 push button switches, 4 in the front and 8 in the on top. Now I'm going to turn on the Telepod and show you how I can move it in both azimuth and elevation. Move the camera. Okay, I turned on the VEX Cortex, and you can see here that it's trying to synchronize. Now all 3 green lights on the VEX controller are lit, so that means that I have full communication with the VEX Cortex microcontroller on the Telepod. All right, I'm going to start slowly moving it. I'm moving it in elevation. You can see the camera slowly moving up. Now what's nice about this system is that it's totally trainable. You can teach it what positions you want. So if you're at an event, you could teach it where to point to, what locations automatically. All right, and you train it with the joystick, and you record the motions, and then later, when you're ready to film the event, you can press play, and the camera will automatically repeat all the positions that you originally trained it for. This is one of the features that's really nice about this system. All right, now I'm going to move it in azimuth. You can see it turning. And you could use this to slowly pan at an event too. You could slowly pan, what's going on, and you could do it from across a basketball court or across a football stadium. This is very similar to what TV stations would have, except they have, those balls that control the cameras and but you can put a pretty heavy camera on this. Of course, the brackets that I'm using right now are not too sturdy, and you can see a lot of vibrations there. For the real system, you would need a much sturdier frame that wouldn't vibrate. But the motors are certainly powerful enough to move the camera in any direction. Some of the brackets that I used for the project, I just bought at Home Depot or Lowe's. Here you can see the limit switches on the elevation drive. There's two of them, those two VEX limit switches, and they prevent the elevation drive from exceeding the mechanical limits, so that the camera isn't damaged and the frame, or the telepod frame, isn't damaged. From this angle, you can see the VEX quadratron encoder that I used that measures the azimuth angle, which can move anywhere from 0 to like 250 degrees, or maybe 270 degrees. The reason being that it shouldn't continually turn, or it would rip the wires apart. And that's why I also have two azimuth limit switches that prevent it from turning too far, exceeding the 250 to 270 degree limit in azimuth. These sensors are really required because for remote operation, you don't know how far you're going to drive it in azimuth or elevation using the remote joysticks, using the game controller. From this angle, you can see the azimuth motor, which turns out to be just a electric car window motor. They are very powerful because they have to lift heavy glass in your cars. And it drives the azimuth axis or platform really nicely. This is a close-up of the hardware used in the system for the Telepod. I also used VEX gears to interface the motion from the azimuth axis, the azimuth motor drive, to the quadratron encoder. The VEX, that's that red box with the large green gear on top. This was a way of interfacing non-VEX components to the VEX system components. The servo driver shown here, the servo motor, is, like I said, very powerful, and it does have a built-in quadratron encoder, which I then interfaced to the VEX microcontroller, shown right here. Okay, this is the back side of the Telepod. You can see the VEX controller more clearly from this angle, as well as you can see the azimuth motor, the geared azimuth motor, which is the electric window motor. The blue 9.6 volt battery is all that's needed to power this entire system. Although you can use a 12 volt SLA battery, and you can even use the standard 7.4 volt RC battery that's normally used with VEX systems. This is the top view of the system. As you can see the azimuth motor and the elevation motor from the top. Here you can see the VEX microcontroller with all the wires interfaced to it. The wires come from the motors and from the sensors. For some of the motors I use the VEX 3-wire to 2-wire converter because I originally used a VEX 0.5 microcontroller, but since I've upgraded it I really could remove those two controllers and adapters and just connect it to the 2 DC ports that are built into the VEX Cortex. Here's a top view of the VEX quadrature encoder assembly. Just another angle to see it. Now I'm going to move around the telepod again. I'll move it in azimuth and elevation from this side and see what you think. Want to take pictures of the moon. You could use this to keep track of the moon too. This Nikon camera with the lens is pretty heavy, so I probably should counterbalance the elevation axis to make it move smoother. I will cover the feature called the motion script generator that allows you to train the telepod so you can teach it different positions and then have them to record the different positions and then play them back again later. I'll cover that in another video coming up soon. Thank you. Bye.